All right, the next conic section we're going to look at is an ellipse. And an ellipse happens, it is of this type 2, when you cut a cone with a plane like this, you're going to have a circle, and when you cut it at an angle, you're going to have an ellipse. So the geometric definition of an ellipse is going to be the set of all points in the plane such that the sum of whose distance from the two fixed points f1 and f2 is constant. What do I mean by that? So all the points x and y, if I add the distance between the point P and a fixed point f1 with the distance from the same point P to another fixed point f2, the sum is always going to be a constant number, which means it's always going to be the same number. So if I move on to another point right here, P2 for example, the sum between P2 and F1, the distance between P2 and F1 and P2 and F2 is the same as the sum between P and F1 and P of F2. So this sum is always going to be the same. So this is how we construct an ellipse. We are going to concentrate for now on ellipses, these fixed points F1 and F2 are called foci, or the plural of focus. So if we place them on the x-axis, so we're going to look at the center of the ellipse being at the origin of the plane xy, and we're going to place the focus f1 and the focus f2 on the x-axis. So this is what we're going to do for now, and then in section 11.4 we're going to let this move around and not just have it at the origin. So if you want the derivation of the formula for an ellipse, you would have to say that the distance between the point P and the focus 1 plus the distance between the point P to the focus 2 is a constant number. The derivation of the formula will take a lot of time and is not necessary, but if you want to look at it, it's in your textbook in the section 11.2. It's just a little too much algebra to go over. All right, so let's see the equation of an ellipse. How does it look like? So first of all, we're going to have two types of ellipses. We're going to have an ellipse where the focus, the foci, both of the I can't say that word, where the focus is on the x-axis and where the foci are on the y-axis. So those are the only two types. So the equation of an ellipse is going to be x squared plus over a squared plus y squared over b squared equals 1. So this is for when the focus 1 and focus 2 are on the x-axis. So both these numbers a and b have to be greater than 0, and a has to be greater than b. We call the x-intercepts. How do we find the x-intercepts from here, for example? The x-intercepts are where the y is 0. So if you set y equal to 0, you will get that x squared over a squared equals 1, which gives you that x squared equals a squared. So the x-intercepts are going to be at a and minus a. So we call the x-intercepts the vertices. So the vertices are the x-intercepts. So there's a lot of terminology that comes in with an ellipse. So the vertices are just plus or minus a and 0. Then the horizontal, so if a is an x-intercept, that means the distance from the origin to a is a, and then the distance from the origin to negative a is also a. So the distance between the vertices is 2a, and that is called the major axis. How do I find the y-intercepts? The y-intercepts, I'm going to set x equal to 0 in here, so I would get y squared over b squared equals 1. So I will get y squared equals b squared. So the y-intercepts are going to happen at b and at negative b. Then the distance between 0 and b is b, and the distance between 0 and negative b is another b. So this whole distance is 2b, and we call that the minor axis. We call that major and this minor because we're in the case where a is greater than b. So you see the distance from 0 to a is greater than distance from 0 to b. Then we saw that the foci happen at c0, so and then negative c0. And we also have that c squared equals a squared minus b squared. So this is the relationship between the foci, and the a and the b, where the a is half of the major axis and b is half of the minor axis. So when a is greater than b, so when the number associated with x squared is greater than the number associated with y squared, the foci are going to be on the x-axis. On the other side, if a is greater than b, but a is associated with y squared, this is plus, then the foci are going to be on the y-axis because the greater number a is associated with y. So the foci are going to be on the y-axis. So you're going to have the coordinate of the first or second foci is this point, which is 0 for x and c for y. So 0c. And then correspondingly, the other one is 0 for x and negative c for y. Then the x-intercepts are going to be b and negative b, because I set x equal to y equal to 0. So I'm going to get that x squared over b squared equals 1. So the x-intercepts are going to be b and negative b. So then the vertices now are going to represent the y-intercepts. So the vertices are going to be 0 and plus or minus a because they represent the y-intercepts. So the vertices are the ends of the major axis. So in our case, the major axis right here is going to be the vertical length, and the minor axis, the smaller one, is going to be the horizontal line. And the foci, since they're on the y-axis, their coordinate is 0 plus or minus c, compared to plus or minus c 0 when they were on the x-axis. And we still have that c squared equals s squared minus b squared. All right, so what we need to remember, the equation of it, and then we need to remember that the larger denominator is going to determine if the foci is going to be on the x-axis or on the y-axis, and then that the major axis is the one that comes with the foci, and the vertices are the end of the major axis. So let's see. This is pretty much, well, there's one more piece of, or another formula for the eccentricity of an ellipse, but that's all the stuff that comes in with an ellipse. So we need to find the foci of the ellipse 16x squared plus 9y squared equals 144. So the first step will be, well, I need to write it in the form of one of these equations. So I either need to write it as x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. So how can I make it look like one of these? Well, first of all, this 144 right here is bothering me. I need it to be a 1 because that's what the formula says, either one of the formula. So we're going to divide everything by 144. So that's going to give me 16x squared divided by 144 plus 9y squared divided by 144 equals 1. So now I took care of the right hand side is in the form I want. The left hand side, I need the x and the y to be isolated. So I'm going to rewrite this as x squared divided by 144 divided by 16, because this is the same as 16x squared over 144 plus y squared over 9 equals 1. X squared divided by 144 divided by 16, I can reduce that, and that's 3, so that's 9. 9 times 16 is 1, is it 9? Yes, this is 9, and this 144 divided by 9 is 16. Okay, so I brought it in the form I needed. So now I gotta decide, is it of this type or of this type? Who has the greatest denominator? The x squared or the y squared? Well, this one has the greatest denominators because 16 is greater than 9. So that means that my a, the one that needs to be greater than the other one, is 16. And we are in this case. The greater denominator is with the y. So a is 16, and then b is, actually a is not 16 but 4. And b is 3, because a squared is 16, right, in here, and b squared is 9. And since I'm working with positive numbers, I need to have that a equals 4 and b equals 3. And I'm going to have an ellipse with the foci on the y-axis. Okay, because we are in this case, because the y had the greater denominator. So then let's sketch its graph. So to sketch its graph, I need to know the foci. And the foci are going to be 0 plus or minus c. And then the major axis, it's going to be on the y-axis. This is on the y-axis. The minor axis is going to be on the x-axis. Let me just draw it. So I know that a is 4, so I'm going to have that the vertices are 4 and negative 4. So 4 and negative 4. So this is the major axis, and then the minor axis is given by b and negative b, and b is 3, so it's going to go 1, 2, 3, 1, 2, 3. Alright, so then I can draw the ellipse already. And I also need to find the foci. That's what this is. So the foci is given by c squared equals a squared minus b squared. So c squared is going to be a squared, which is 16, minus b squared, which is 9. So c is going to be 7. So the positive root of 7 is going to be square root of 7. Because all of these, c is a positive number. Okay, so square root of 7 is between 2 and 3. So somewhere in here will be the foci. So this is positive 0 for x and square root of 7 for y, and then this one, the second foci, is 0 minus square root of 7. So the fact that the greater denominator happened for y told us that we're going to have the major axis on the y-axis. Okay, so then another problem. Let's find the equation and sketch the graph for this ellipse, and they're giving us that the vertices are at plus or minus 4. So the vertices are on the x-axis, right? So the vertices are on the x-axis and they're at plus or minus 4. So the foci are going to be on the x-axis, right? Because the major axis, the vertices happen with the major axis. If the foci are on the x-axis, the vertices are going to be on the x-axis. If the foci are on the y-axis, the vertices are on the y-axis as well. So the fact that the vertices are negative, plus or minus 4 and 0 is telling me that I'm going to be in the case where the foci are on the x-axis. And that is also explained by the fact that the foci are plus or minus 2 and 0. So the plus or minus 2 is right here. So those are the foci, and those are the vertices. So the only thing I need to find, so this is the equation of it. I know that a is 4. So far the equation is x squared over 4 squared plus y squared over b squared equals 1. So I need to find b. Should b be greater than a or smaller than a? Well, since it's an ellipse on the x-axis, the denominator that comes with the x is going to be larger. So when we find b, we better get a number less than a. So who's going to give us b? We know that c squared equals a squared minus b squared. And I know that c is 2, so it's going to be 4 squared equals 2 squared. C is 2 equals 4 squared minus b squared. So I get that 4 equals 16 minus b squared. So I subtract 16, so I'll get negative 12 equals negative b squared. So 12 equals b squared. The positive root of 12 is going to be square root of 12. And if I want to reduce this, this is square root of 4 times 3. And that's square root of 2 with 4, which is 2 times square root of 3. So now I can rewrite the equation x squared over 16 plus y squared over, well, b squared is 12 equals 1. So this is the equation of the ellipse that we are looking for. And to graph it, I just need to plot my positive b and negative b. So let's say this is square 2 root 3 or square root of 12. And this is negative 2 root 3 or negative square root of 12. And then I can draw the ellipse. What would have to happen for an ellipse to be a circle, actually? Well, we would have to have that the minor axis and the major axis are going to have to be equal. So to have a circle, we should have that the A and the B are the same. So for it to be a circle. We will talk more about circles in 11.4. So the other piece of information about ellipses is this measure called the eccentricity, and it measured the deviation of an ellipse from being circular by the ratio of A and C. So if you have an ellipse either on with the foci on the x-axis or with the foci on the y-axis, the eccentricity is denoted with E and is the number C divided by A, where C is just your regular C that comes from C squared equals A squared minus B squared. And the eccentricity has the property that it's always a number between 0 and 1. So let's find the equation of an ellipse that has these foci. Okay, so as soon as you get a piece of information, start drawing. So it's 0 plus or minus 8, so 0 for x and 8 and negative 8 for y. So this is going to be an ellipse with the foci on the y-axis. Okay, so then eccentricity is E equals 4/5, but I know by formula that the eccentricity is C over A. So C over A equals 4/5. But C is given to be 8, right? Because the foci is 0 plus or minus C. So C is 8. So that means that 8 over A equals 4/5. That gives us that A equals 8 times 5, which is 40, divided by 4. A equals 10. So remember that A equals 10. A was the larger one. So A equals 10 is going to give me the vertices. The vertices are going to happen at 10 and negative 10. Right? They go with the major axis. So far, our equation is going to be x squared. What should I put in here, A or B? So the foci are on the y-axis. So the highest denominator, A, is going to go with the y. So it's going to be 100 because of A squared is 100. And then the B squared is there. So all we need to do is find B squared, or B. So I know that C squared equals A squared minus B squared. So C squared, C is 8. So it's going to be 64 equals 100 because A squared is 100 minus B squared. So negative 36 equals negative B squared. So B equals 6. So that means that my equation, instead of B squared, I'm going to put 36. And that's going to be the equation. So notice that B is the smaller denominator, and that goes with X. So the bigger denominator goes with Y because the foci are on the y-axis. So then I'm going to put 6 here and negative 6 there, and I'm going to draw my ellipses. Alright, so this is it about ellipses. There are more videos in WebAssign with specific problems if you need more help, but it's going to come down to understanding these two situations. Where is it a ellipse like this with the longer side on the y-axis, or when is it an ellipse with the longer side on the y-axis? And you'll just have to practice and get used to these this terminology.